Let's look at more examples of Hess questions. That is a continuation from where we stopped, where we are just going to give the same equation, and that equation will use to further calculate the enthalpy of formation of methane. So, example, given that carbon plus oxygen react to form carbon dioxide, delta H is negative 393 kilojoule per mole. H2, that is hydrogen, combustion to give water, negative 286 kilojoule per mole. Methane reacting with oxygen gas to form carbon dioxide and water. That is delta H negative 890 kilojoule per mole. Questions. Part A. Draw an energy cycle diagram, just the same. Linking delta H formation of methane and delta H combustion of methane and delta H combustion of hydrogen and carbon. So that is carbon plus hydrogen leads to formation of methane. This is delta H formation of methane. Combustion, carbon will give us carbon dioxide, hydrogen gives water. So for 2 moles of water, we call for 2 moles of hydrogen, and that is also undergoing combustion. It requires oxygen, and indeed that is 2 moles of oxygen. Delta H combustion of methane so oxygen is now 4. Oxygen is balanced. This other side, oxygen should be 2 plus 2, which is 4. So we generally have 2 moles of oxygen gas, and this is delta H1, delta H2, delta H3. Part C of the question, calculate the enthalpy of formation of methane. We have stated that is delta H1, which can be through delta H2 minus delta H3. But we can first determine delta H2. But delta H2 involve combustion of carbon and hydrogen. Remember, in the illustration, in what is given above, it is 1 mole of hydrogen undergoing combustion. But now, we have 2 moles. So therefore, delta H2 will be first 2 times that of hydrogen, that is 286, plus that of oxygen, which is that of carbon, which is still 1 mole, and therefore we simply take minus 393 everything kilojoule per mole. Let us connect the two. So that is minus 286 times 2, giving us negative 572, then minus 393 will give negative 965 kilojoule per mole. That is the delta H2. Therefore, delta H1 will be minus 965 minus, it is minus, and then delta H3 also has a negative value. So that is minus H3. And remember, H3 involve combustion of 1 mole of methane, and that is negative 890. If we work out this well, what are we going to obtain? Plus 890 gives minus 75 kilojoule per mole. So now, that is the enthalpy of formation of methane. Thus, delta H formation of methane is equals to negative 75 kilojoule per mole. Part D of the question, draw or represent this in an energy level diagram. So draw an energy level diagram linking the three enthalpy changes. So that is y-axis, x-axis. So we have some combustion, so carbon and hydrogen undergoing combustion to form carbon dioxide gas and water. This can also form just methane. So that is plus oxygen gas, and they are forming methane plus oxygen. That gives that. So 2 moles of oxygen. So we have delta C combustion is negative 890 kilojoule per mole. That one is delta H formation, which is negative 75 kilojoule per mole. Then this is delta H combustion, that is negative 965 kilojoule per mole, connecting the two. So this is enthalpy. Then we have reaction path. That is the full illustration of that in the energy cycle diagram. And it has connected well all the three. The product here is 2 moles, very important to indicate that. Then oxygen automatically will be balanced if we have 2 there. Good. So that is the energy level diagram linking the 3 enthalpy changes. Another example. Ethanol can burn or simply write ethanol can't be prepared directly from its elements. And so its standard heat of formation must be obtained. Question 1. Write an equation for the formation of ethanol from its elements. So that will be carbon plus hydrogen plus oxygen, forming 1 mole of ethanol. So that is a half 3 2. Part B of the equation, draw an energy cycle diagram linking the formation of ethanol from its element and combustion of ethanol. So we have carbon 2 plus 3 moles of hydrogen gas plus half oxygen, giving C2H5OH liquid. When that undergo combustion, we'll have carbon dioxide and water, that is 3 2, and that also undergoing combustion will give same carbon dioxide and water. So hydrogen requires 3.5 oxygen to form the hydrogen, that is 3.5, that is 3. Okay, this one will be forming 4, so we have 2 moles of oxygen gas required. So now we have the energy cycle diagram. Next question, part C. If given the following heat of combustion, that is heat of combustion of graphite as negative 393 kilojoule per mole. Heat of combustion of hydrogen negative 286 kilojoule per mole, and heat of combustion of ethanol to be negative 1368 kilojoule per mole. Now we want to calculate the heat, so that is calculate heat of formation of ethanol using our energy cycle diagram. We want to call this delta H1, delta H2, delta H3. So to obtain delta H1, it is H2, then opposite of H3. As we said earlier, the H1, which is formation of ethanol, will be delta H2, that is combustion of carbon and hydrogen, minus delta H3 for the combustion of ethanol. But delta H2 will involve the two substances, that is combustion of carbon and that of hydrogen. Remember, in the data given, it is only combustion of 1 mole of carbon. But in the energy cycle diagram, we have used 2 moles of carbon, so that will be 2 times negative 393 plus, again for hydrogen, we have been given the heat of combustion of 1 mole, molar heat of combustion. But we have used 3 moles of hydrogen gas to balance the equations. So that means, again, 3 into minus 286. So this totals to, the first one is 2 times negative 393, that is minus 786, then minus 3 times negative 286, 858. If you sum up, what do you get? Negative 1644 kilojoule per mole. Now that is what we have. Let's continue. Delta H1 therefore will be delta H2, which is negative 600, or rather 1644, minus 1368 for the combustion of ethanol, and that gives negative 276 kilojoule per mole. So that is the heat of formation of ethanol. So that's heat of formation of ethanol is equals to negative 276 kilojoule per mole. Part D, we want now to draw an energy level diagram linking the three enthalpy changes. So D, draw an energy level diagram linking the three enthalpy changes. It is y-axis, x-axis, so we have carbon 2 moles plus 3 moles of hydrogen reacting with half a mole of oxygen to give methane, or simply ethanol. Then that is plus oxygen, in fact 3 moles of oxygen, so to balance up we'll have 6 plus 1, 7. So finally that gives the final product down here, and that is carbon 4 oxide and water 3, 2, and they have their general delta H, which is negative 1644 kilojoule per mole. That is delta H is equals to negative 276 kilojoule per mole, and this is delta H is equals to negative 1368 kilojoule per mole. So that is the illustration in the energy level diagram. So we have this as the reaction path. So we have 7. So this has to be 3.5. 3.5. That is what will balance up the equation well. Three and a half, simply 7/2, so that we balance the oxygen all sides. Now we have this as the enthalpy in kilojoule. That is the energy level diagram that has represented the three enthalpies. Our last example, which we want to try to involve the addition formula, so that we connect the addition formula and the use of energy cycle diagram. Another example, propane is a common fuel used in school laboratory. The heat of combustion of propane carbon and hydrogen are given below. So the first one, we have C3H8 plus 5 moles of oxygen, giving 3 moles of carbon dioxide and 2 moles of water. Delta H is equals to negative 220.1 kilojoule per mole. The second combustion, carbon plus oxygen gives carbon dioxide gas. That is delta H is equals to negative 393.5 kilojoule per mole. Then hydrogen, half a mole of oxygen to give water. Delta H is negative 285. What is that? 0.8 kilojoule per mole. Part A. Write equation to show formation of propane from its elements. So that will give carbon plus 4 moles of hydrogen gas to form C3H8 as the propane gas. Part B. Calculate the enthalpy of formation of propane using energy cycle diagram. Of formation of propane using energy cycle diagram. So we start by having the energy cycle diagram, then we do the calculation. So that is carbon plus, first of all, this equation has to be balanced. Very important by having there 3. So we have the calculation energy cycle diagram, that is 3 carbon plus 4 moles of hydrogen gas giving C3H8, that is delta H1. Then we have combustion of carbon with 3 moles of oxygen gas, then combustion of hydrogen, 2 moles of oxygen to form carbon dioxide and water. Then combustion of propane with 5 moles of oxygen gas. To balance the equation, we must have 3 carbon and 4 water. Let's check. The hydrogen has to be 4. Water, so that we balance the 8. To balance the equation, carbon 3, oxygen 5 moles of oxygen giving us 10. So that is 6 plus 4, 10. Then methane, propane has 3, okay. Hydrogen 8, hydrogen 8. So the equation is balanced. This is what we call delta H3. Then the whole of this is delta H2. Gas, liquid gas, oxygen gas, oxygen gas. So in the calculation, we have delta H1 is equals to delta H2 minus delta H3, but delta H2 is equals to 3 times that of carbon, because we have used 3 moles of carbon in the cycle diagram. So that is 3 times negative 393.5. Then we'll add that of hydrogen, which is also given as 1 mole, but we've ended up using 4 moles. So that is minus 393.5 plus 4 into negative 285.8. That gives 3 times 393.5. That is negative 1180.5 minus 4 times 285.8, giving negative 1143.2. Our overall delta H2 is equals to negative, let's subtract that, so it is 1180.5 plus 1143.2. That gives negative 2323.7 kilojoule per mole. Because it is not kilojoule per mole, because we are not dealing with 1 mole now. Good. It is not 1 mole. Now, that is our delta H2. Therefore, delta H3 is equals to, our delta H3 is equals to negative 2220.1 kilojoule. So this implies that delta H1 is equals to minus 2323.7, then minus 2220.1, and that will give negative 2323.7 plus 2220.1, which finally gives negative 103.6 kilojoule. And because we are forming 1 mole, it is now kilojoule per mole. We can show the same in an energy level diagram. Show part C, show in an energy level diagram. So we'll have y-axis, x-axis, y-axis. So we have that is that 3 of carbon solid plus 4 of that plus 5 moles of oxygen gas. That will give full product of C3H8 plus 5 that gaseous. So this is carbon dioxide and water. Delta H there is negative 103.6 kilojoule. That is for the formation. We are forming 1 mole actually. Then we have the overall as delta H2, which is minus 2323.7 kilojoule as the overall. Then down we have negative 2. This is delta H. Delta H is negative 2220.1 kilojoule. To balance up, we have 4, 3. Then our equation is balanced. Now, let us look at the addition formula of calculating, or rather, trying to calculate the enthalpy using addition formula. Just the same example. Step 1, multiply equation 2 by 3 to get or to give 3 carbon solid plus 3 oxygen gas, forming 3 of carbon dioxide. Delta H for that is minus 1180.5 kilojoule. Step 2, multiply is a very simple one. Equation 3 by 4 to obtain 4 hydrogen gas plus 2 oxygen gas to give 4 of water. Delta H for that is minus 1143.2 kilojoule. Then add equation 4 and 5 to obtain. This is what we call equation 4. Then this is our equation 5. Equation 4 to 5 to obtain 3 of carbon solid plus 4 of hydrogen gas plus 5 of oxygen gas, forming 3 carbon 4 oxide gas plus 4 moles of water, and delta for that is minus 2323. So we're done with that. Next step, subtract equation 1 from the so formed equation, that is equation 6, to obtain what we are going to obtain from there is simply that the carbons, some will cancel out. So we have in equation 6 3 carbon solid plus 4 hydrogen gas plus 5 oxygen gas. Then we subtract C3H8, that is equation 1, minus 5 oxygen. Reactant side well subtracted. Product will have 3 carbon 4 oxide plus 4 water minus 3 of carbon 4 oxide minus 4 of water. That is equation 1 from 6, not the reverse. So some will cancel out. 5 oxygen minus 5 oxygen. This is carbon, 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 carbon. So that we have the values as well will be subtracted. If you subtract well, you will get delta H is equals to minus 103.6. So we have 3 carbon solid plus 4 hydrogen, then it is minus this, so it is forming C3H8, and delta H is minus 103.6 kilojoule. So that is how we obtain that using addition formula. Remember, what we are calling equation 1, 2, 3 is just the same way they are organized in the example, the way they are written. So this is what we are calling equation 1, this is equation 2, then this is equation 3. So when we say subtract equation 1, then this is the equation we are subtracting. Multiply equation 2, then multiply equation 3. So that is all about Hess law, and we have looked at that using both addition formula and using Hess law involving energy cycle diagram. So normally you can decide on which to use, but only when the question is open. The moment the question requires Hess law by energy cycle, then you must go for energy cycle diagram, because it is this energy cycle diagram that will ease your work when you want to come up with an energy level diagram.